Hello, students. Welcome to Visionary Heights. Today, in the Grade 10 chapter series, we're gonna start new chapter that is real numbers. In this chapter, I'm gonna show you the logic behind the number system, from the fundamental theorem of arithmetic to the secrets of the prime factorization. I have designed this video so that once you finish it, you can solve any chapter 1 question with 100% confidence. So grab your notebook and a pen and let's start the chapter. Before we start any chapter, it should be clear what the chapter is about. See, we are talking about the real numbers here. So before we move to the real numbers, before we start maths is about numbers, right? What are numbers? They're just the notation for which are used to count, right? Which are used to measure something, which are used to label something. Suppose I have to show 5 kg, so I will use a denotation by 5, right? So they are just the notation. Clear? Alright, coming to the real numbers, the very basic thing that is there is the natural numbers. Okay, many of the students get confused. What are natural numbers? What are whole numbers? What are integers? Let me explain this very clearly with the help of a story, right? Suppose you are going to a shopkeeper, right? And you are asking for some chocolates. Give me 2 chocolates, give me 5 chocolates, give me 10 chocolates. You will ask like that, right? All those numbers that you can think of, they all are the natural numbers. You will ask like, give me 1 chocolate, give me 2 chocolate, give me 3 chocolate. You will not ask for the portion of it, right? So from the shopkeeper, you will ask for the complete chocolate. So those complete numbers are starting from 1 to infinite. They all are known as the natural numbers. Now one more thing can happen there, that the shopkeeper may say, sorry, I don't have any chocolate. I don't have any chocolate means 0, he is saying, right? So if to the natural numbers I add 0, they form the whole numbers. Now how the shopkeeper can answer? Okay, I have 5 chocolates. 5 is also a whole number. 5 is also a natural number, right? Or he can say, sorry, I don't have any chocolate. He will use 0. 0 is also a whole number. Clear? The way how you will ask the shopkeeper, 1, 2, 3, 4, 5, 6, 7, 8, 1000, 10,000, all these are the natural numbers. But if to the natural numbers you add 0, they become the whole number. So whole numbers means 0 to infinite, means all the complete numbers as well as 0. Clear? Now we have the integers. Integers means whatever numbers we have written in natural numbers, if I put a negative sign over there. Alright. So negative numbers and the whole numbers, they form the integers. If I ask you what is minus 5, minus 5 is integer, right? It is minus of a complete number. So it is a integer. If I ask you what is a 10, so 10 is a natural number as well, 10 is a whole number as well, and 10 is a integer as well. Hope integer is clear. Now we have the rational number. What are the rational number? So to the integers, if I add the fraction, what is the use of the fraction? Suppose you bought a chocolate and I ask you to give half of it to your mother. What you will be doing? Half means 1 by 2, right? So this thing, when I have to write the portion of something, I will need the fractions as well. Na? So if to the integers, to the all the complete numbers, whether it is 0, whether it is positive, whether negative, if I add the fraction, then they will form the rational numbers, right? Later we will come to know that rational numbers can be written in P by Q format. P and Q should not be integers. We will learn all these things later, right? For now, we are just defining what are all these things. Clear? What are irrational numbers now? Irrational numbers means which can't be written in the form of a fraction. Like the rational numbers were the complete numbers like 5, 7, or it can have 0 as well. We can have negatives as well, right? We can have the fractions as well. But irrational numbers means that can't be written in the fractions. Or we can say all those numbers whose root we can't remove, like root 3, root 5, minus root 7. All these type of numbers are the irrational numbers. Okay. The combination of all the numbers rational, either they are rational means they can be natural, they can be zero, it can be a fraction, it can be a positive number or a negative number, or those numbers are rational. And irrational means the numbers which are written under root, right? Root 3, root 5, root 7. The combination of all these type of numbers are known as the real numbers. Now you may say, ma'am, whatever numbers we can think of, you have given us all the numbers, then why they are real numbers? Why not numbers only? Because in the higher grades you will learn that we have one more type of number. See, if I ask you x square equals to 25, tell me the value of x. What you will say? Ma'am, x will be plus 5 or x can be minus 5, right? But if I ask you, tell me that number whose square is minus 25. Is it possible? Whatever we have learned so far, we don't know how to find that number. If we do the square of that number, we are getting a negative one, right? Because the square will gives us positive, right? So these type of numbers that we are going to deal with, these all are known as the imaginary numbers. They are not in the 10th grade syllabus, so we are not learning them. The point is, real numbers means all those numbers, positive, negatives, fraction, zero, or irrational number like root 3, root 7, root 10, all these type of numbers we have to deal with. Okay, let's solve some of the question. If I ask you about 10, so 10 is a natural number because I can ask the shopkeeper, give me 10 chocolates, right? So it is a natural number. If I ask you about whole number, yes, it is between 0 to infinite. If it is natural, it is whole number for sure, right? It is an integer as well because it is a positive number side, right? It is a rational number as well, and when it is rational, it is a real number. Okay, we can say if something is natural, if to the natural number I add 0, I will get real numbers. I will get the whole numbers. To the whole numbers, if I add the integers, I will get what? To the integers, I will get the rational number and all the fraction if I add, right? And then irrational plus rational will form the real numbers. Clear? So if I ask about 0, 0 is a natural number? No, 0 is not a natural number. But 0 is a whole number. 0 is an integer as well. 0 is a rational number as well. And 0 is a real number as well. Clear? Like that, we have the numbers. Now let's come to the chapter now. The most important things that we should know is what are prime numbers, what are composite numbers. So if I ask you what are prime numbers? Okay, so prime numbers means those numbers which have exactly two factors. Exactly two factors. Factors means exactly two numbers will be there which can divide that number. Okay, simply factors you can see for now is that those numbers which can divide a given number, right? Suppose I am talking about 5. So 5 is divisible by 1. 5 is divisible by 5. Means exactly two numbers are there. What are those two factors? For each number it will be 1 and the number itself. Okay, because every number can divide itself, right? If I'm asking about, okay, tell me about 7. 7 is divisible by 1 means, and the number itself means 7. So these are the two factors. All these type of numbers are known as the prime numbers. If I ask you what is the smallest prime number, is 1 a prime number? Tell me. No, 1 is not a prime. Why 1 is not a prime? Because 1 is divisible by 1 only now. Is there any other factor? No. So there is only one factor, so 1 is not a prime number. Because prime number says there should be exactly two factors. So if I ask you the smallest prime number will be 2 because 2 has two factors. What are those? 1 and 2. Is this clear? What are prime numbers? Okay. Composite numbers means which have more than two factors. They have more than two factors, means more than two numbers can divide them. For example, suppose I ask you about 4, right? So 4 has how many factors? How many numbers can divide 4? 1 can divide 4, 4 can divide 4, and 2 can divide 4, right? So these are the three, means more than two factors are there. If I ask about 10, so what are the numbers which can divide 10? 1 can divide 10, 2 can divide 10, 5 can divide 10, and 10 itself can divide. Means 1, 2, 3, 4. 4 factors. Now means more than two factors. If a number has more than two factors, they are known as the composite number. So simple definition is prime numbers means exactly two factors, means they are just divisible by 1 or the number itself. But when we talk about the composite numbers, along with the 1 and the number, they are divisible by some additional numbers as well, right? Like 10 is divisible by 1, 10, and 2 and 5 as well. Clear? So what is the smallest composite number? Smallest composite number is 4. Is 1 a composite number? No, because 1 has just one factor, right? It is neither prime nor composite. So 1 is neither prime and it is nor composite number. Clear? Now we have two things here, very very important. What are HCF and what is LCM? HCF, if I try to define, it is highest common factor. Highest means it should be the greatest, it should be common in both the terms, and factor. Factor means the number which divide the given number, right? So if I ask you about two numbers are given, right? 12 is given, okay, and 8 is given. If I try to find the HCF of it. So HCF means highest common factor. Factor, as I told you, all those numbers which can divide a given number. So if I ask you the factor of 12, what are the factors of 12? 12 is divisible by 1, good, 2, 3, 4, 6 and 12, right? You can see like that as well. 1 into 12, 2 into 6, then 3 into 4. No number in between, right? Similarly for 8, I can write the factors like 1, 8, then 2, 4. Is there any number in between which can divide them? No, only 3 is there. That by which it is not. So what is the common here? In the 12 and 8, 1 is common. Yes or no? 2 is also common. So common factor means, what are the common factors? 4 is also common, right? But HCF means we have to find the common factor and that should be the highest. So 1, 2 and 4. What is the highest? 4. So HCF of these numbers will be 4. Clear? Similarly, when we talk about the LCM, LCM means they are the multiple. If I ask you about the multiple of 8 and 12, so 12 multiple will be, one time multiple it is 12 only, 2 times it will be 24, then 36. If I multiply it with 3, means I am multiplying something with the number, so it will go on increasing, yes or no? If I talk about 8, then 16, then 24 and so on. Something like this, right? Okay, now if I ask you one thing, can I find the highest multiple here? Not possible, because I can multiply a number of things, right? The highest multiple is not possible, na? So we have to find the lowest common. So what is common in these two? Low and should be the lowest. 24, right? So 24 will be the LCM. Hope it is clear. In HCF, we have to find that number which can divide them and should be the highest. In the LCM, we have to find that number which is a multiple of these numbers, and that should be the lowest. Now you can ask me one thing, ma'am. Okay, these numbers were smaller, so it was very easy to find the multiple or the factor. Means if I'm talking about the HCF, so it's very okay. It's practical that we can find all the factor. But what if the number is very big? Do we have to write like this again and again? No. We have one more method. What's that method, dear? See, if I have to find the HCF of two numbers, suppose I have to find for 12 and 8 only, I will write their prime factorized form. Prime factorized form means I will try to write these numbers in the multiple of primes. Okay, how to write 12? 12 will be 2 into 2 into 3. How to write 8? 8 is 2 into 2 into 2. This is the, okay. Is there any other possibility? Why I have not written 1 here? Because prime factorization, we have the prime numbers only. 1 is not a prime, right? So I have not written 1. Okay. So if I see what happens now, if someone try to write 12, so 12 can be written as 2 into 6. Okay, someone will come to me, ma'am, it is this one, right? So we have different ways, or someone will tell me, ma'am, it can be written as 4 into 3. So there are different ways of writing a number. Okay, but if I want a unique thing that everyone will be having the same, so I can use the prime factorization, right? If I ask you, is there any other way by which I can write this prime factorization? No, it's the unique one. If I am solving it or you are solving it, you will write it like that only, right? What you can, if you can want to show me something, some change now, you can just write them like this. Okay, the order can change, only the order will change, but it will not change the numbers. Means how I am writing them, that will be a unique thing. Is this clear? So now how to find the HCF here? See, what is common in these two? This 2 is also common. Okay, what else is common? Highest thing that is common, this 2 is also common. So means 4 is common, so their HCF will be 4. Any doubt in this? Alright, so we can move further. If we try to find, we have fundamental theorem of arithmetic. Now what is fundamental theorem of arithmetic? Whatever we just discussed now, that was fundamental theorem of arithmetic only. So fundamental theorem of arithmetic says that every composite number means those numbers, very good, those numbers which have more than 2 factors, they can be expressed or they can be factorized as a product of primes. We already discussed, whatever is a number, suppose 10 is my number, right? So 10 can be represented as product of its prime, right? So how to write 10? 2 into 5, right? And this factorization is unique. This factorization is unique. There is no another way to write prime factorization of 10, right? Is there any other way? Can you write it differently? Someone can say, ma'am, I can write it as 5 into 2. Okay. See the next line. Apart from the order in which the prime factorization occurs, means you can just change the order, nothing else you can do. You will use the same numbers only. It is unique. Okay. That's why to find the LCM and HCF in this chapter, we will use the fundamental theorem of arithmetic. Now let's do some of the question based on the fundamental theorem of arithmetic. The question is, we have to find the HCF and LCM of 24 and 18. But we have to use the fundamental theorem of arithmetic. What was the fundamental theorem of arithmetic? That we have to first write the composite numbers in the multiple of primes. So if I try to write 24, then prime factorization of 24 will be, we have to find it. So divide by 2, it will become 12. Again by 2, it will give me 6. Again by 2, it will give me 3, and 3, this one, right? So it will be 2 into 2 into 2 into 3. These numbers we have to take, right? All the primes. The second number is 18. What is the prime factorization of 18? Again we need to do the same thing. 2 9 times, 3 3 times, and then 3. So it is 2 into 3 into 3. Now if I ask you what is common in 24 and 18, if I'm finding HCF, means highest common factor, these all are the factors, right? So what is common here? 2 is common, also 3 is common, right? It means what is common in total? 2 into 3. So the HCF will be 2 into 3, or I can say 6. Means whenever I have to find the HCF using the fundamental theorem of arithmetic, first I have to write the numbers in terms of prime factorization form. Then whatever is common, that I have to take and just multiply. Clear? Okay. Now what about the LCM? Again the prime factorization of these two numbers, right? And we have to take the highest power, right? If I take the 24 I can write as 2 to the power 3 into 3 to the power 1. If I take 18 can be written as 2 to the power 1 into 3 square, right? In HCF we are taking the common thing. Common means which is in first as well as in second, right? So I have to take, see, 2 to the power 3 is in first one, 2 to the power 1 is in second one. What is common here? 2 to the power 1 now, because it has 2 to the power 3 means 2 to the power 1 is also there, 2 to the power 2 is also there, 2 to the power 3 is also there, right? So 2 to the power 1 is common. So if I'm solving it like that, I can take the, very good, I can take the lower power. So 2 to the power 1 into 3 to the power 1, 3 to the power 2, what is common? 3 to the power 1. So I can do like that as well. Means I have to take what? I have to take the lower powers if I have converted it into this format, and I can find the HCF. Clear? In LCM what we have to do, because it is a multiple, what should be multiplied, right? So again there are two methods. Either we can find like that, I can take these two numbers 24 and 18 and I can check, okay, divide by 2, it will become 12, it will become 9. Again divide by 2, it will become 6, it will become 9. Again by 2, it will become 3, it will be 9. Then by 3, I will get 3 and 3. Then by 3. Means I can get what? LCM will be 2 into 2 into 2 into 3 into 3, right? Is it okay? Alright. Now according to the fundamental theorem of arithmetic, how to find it? We have to take the higher power. See, 24 can be written as like this. 18 can be written like this. So what is the higher power? Higher power of 2 to the power 1 and 2 to the power 3 is 2 to the power 3. See, I am getting this one. And higher of 3 to the power 1 and 3 to the power 2 is 3 to the power 2. See, I am getting this. Okay. Anyhow, whether I am solving like that or this, I will get the same answer. Means in LCM, if I have converted them into the prime factorization format, I have to take the higher power. Clear? So it will be 8 into 9. So the answer will be 72. Hope it is clear. Let's solve one more question on the same pattern. We have to find the HCF and LCM of 144 and 180. Again the same thing. First try to write 144 into its prime factorization format. So if I try to find out, it will be 144 is 2 into 2 into 2 into 2 into 3 into 3, right? Or I can simply write it as 2 to the power 4 into 3 square, right? Okay. Similarly, I can write 180 as well. 180 is 2 into 2 into 3 into 3 into 5, or I can write it as 2 square into how many 3? 2 and 5 is 1, right? Okay. In order to find the HCF is, there are two ways. Either find the common thing. Common is this is also common, and 3 is also common, one more 3 is also common, right? Either I can write it as 2 into 2 into 3 into 3, or this one more way is there to solve this, that is we can take the lower power, right? Lower power means 2 to the power 4 and 2 to the power 2. Which is lower? 2 to the power 2. So we can write it as 2 to the power 2. 3 square and 3 square. Which is smaller power? So 3 square, right? Okay, and 5 to the power 1, and here we don't have 5. Means smaller is that we don't have 5, right? So it is 4 into 9. That is 36. Means HCF is 36. If I find from this as well, I will get the 36 only, right? Okay, hope it is clear. Now how to find the LCM? LCM was higher power, right? So which is higher power in case of 2? 2 to the power 2 or 2 to the power 4? 2 to the power 4. In 3 square, which is higher power? 3 square is higher. In 5 to the power 0 and 5 to the power 1, which is higher? 5 to the power 1. So this will be your LCM, right? Hope this is clear how to find the HCF and LCM of numbers. Okay. For LCM, you have to take the higher powers. And for HCF, you have to take the lower powers. Clear? Come to the next question now. The question is, you have to find the HCF smallest composite number and smallest prime number. If I ask you what is smallest composite number? Composite number means those numbers which have more than 2 factors. So 4 is the smallest composite number. Yes or no? And smallest prime number is 2 is the smallest prime number. Why not 1? Because 1 is neither prime nor composite, right? So they are asking us to find the HCF of 4 and 2. Again the same method. If I try to find the prime factorization of 4, it will be 2 into 2. And for 2 it is 2 only, right? So what is the HCF of these two? 2 na? 2 is common, right? So HCF is 2. Question was easy, na? Come to the next one. The next question is, P and Q are positive integers such that P is equals to AB square and Q is A square P, right? And AB are prime numbers. It is very important that AB should be the prime number, because if they are composite, we can still break them, right? You have to find the LCM of P and Q. Okay, so try to, again the same thing, try to break this P into the prime factorization. So AB square, P is AB square. How to break it? I can write it as A into B into B. And it is given that A and B are prime, means this will be its prime factorization form. Clear? If I try to find the Q, Q is how much? Q is A square B. A square B. So it can be written as A into B. It means it is its prime factorization form because A and B are prime. Now how to find the LCM of P and Q? LCM means what we have to take, higher power or smaller power? Higher power. So higher power here is A to the power 1, A to the power 2. Which is higher? A to the power 2 is higher. In B to the power 2 and B to the power 1, which one is higher? B to the power 2. So the LCM is this. And if I ask you the HCF? HCF means the smaller power. A to the power 1, A to the power 2. Which one is the smaller? A to the power 1. B to the power 2 and B to the power 1. Which one is the smaller? B to the power 1. So this is your HCF. Clear? In LCM we take the higher power. In case of HCF we take the smaller power. Clear? Now the next question is, LCM of two numbers is 14 times their HCF. The sum of LCM and HCF is 600. If one number is 280, find the another number. Before we start this, let me prove one thing. Now see one thing. If I write 144, what is the prime factorization of 144? It is 2 into 2 into 2 into 2 into 3 into 3, right? Similarly, if I write the prime factorization of 180, it is how much? It is 2 into 2 into 3 into 3 into 5, right? See, if I try to find the LCM of these two numbers will be, see, it is how much? 2 to the power 4 into 3 to the power 2, that is 144, and one it is 2 square into 3 square into 5 to the power 1. So the LCM will be the higher power of 2. So 2 to the power 4, higher power of 3, 3 to the power 2, and higher power of 5, so 5 to the power 1. This will be the LCM. If I ask you the HCF will be lower powers, right? Lower powers of 2, 2 square, lower power of 3, 3 square, and lower power of 5 is 5 to the power 0. We can leave it as it is. We have the LCM, we have the HCF. Now see one thing. If I ask you what is LCM into HCF, see what I am getting. LCM into HCF, this is 2 to the power 4 into 3 to the power 2 into 5 to the power 1 into 2 square into 3 square. Yes or no? Okay. If I ask you what is 2 square into 3 square? 2 to the power 4 into 3 square. This is nothing but 144. See, 144 is 2 to the power 4 into 3 square, right? So it is 144. And what is this? 3 square, 2 square and 5 to the power 1. 2 square, 3 square and 5 to the power 1. It is 180, right? It means what I have proved, that LCM into HCF is equals to multiplication of the given numbers. Is this clear? So I can write LCM into HCF of two given numbers. This is equals to product of the given numbers. Hope it is clear. So whenever I need to find LCM or HCF and product is also given, or one of these two things is given, I can find it directly. Clear? Let's solve some of the question based on this. Now let's see this question. What is given? The LCM of two numbers is 14 times their HCF. The sum of LCM and HCF is given. If one number is 280, find the other number. Okay. So LCM of two numbers is 14 times their HCF. Let's write this, that LCM is equals to 14 times the HCF. What is given next? LCM plus HCF is 600. LCM and HCF, if I add them, it is equals to 600. So LCM plus HCF is equals to 600, right? Now what is given? In place of LCM, I can write 14 HCF. So 14 HCF plus HCF equals to 600. Now 14 HCF plus HCF means 15 HCF. So 15 HCF is equals to 600. Now HCF is how much? 600 by 15. If I solve this, I am getting 40. So HCF I know it is 40. One of the given number is 280. So one number is 280. One more thing I can find from here is, that is LCM. LCM is 14 times HCF. So my LCM is 14 into 40, right? This is my LCM. I have to find the another number. What I have learned now, that LCM into HCF is equals to product of number. Let the number be A and B, right? So LCM is how much? 14 into 40. HCF is how much? 40. One number is given as 280 into another number. So another number B will be how much? It will be 14 into 40 by 280. We can cancel out 14 2s are 28, 2 2s are 4. So my answer is 80. So the another number is 80. Hope it is clear. What we have used here is that LCM into HCF is equal to the product of the numbers, right? Come to the next one. Here the HCF of two numbers is given. Their LCM is also given and one number is given. We have to find the another number. This time what is given? HCF is given, LCM is also given and one number is given. Again the same thing, that LCM into HCF is equals to product of the numbers, right? LCM is how much? 2016. HCF is 9. This is equals to the product of number. If one number is 54, it means 54 into, let the another number be x. We have to find the value of x. So x will be how much? 2016 into 9. If I shift this 54 to another side, it will be in division by 54 equals to x. We can cancel them out, right? Now, how much? 336. It means the another number is 336. Hope it is also clear. Let's see the next question now. Find the least number that is divisible by all the numbers from 1 to 10 and both inclusive. Least number I have to find, or smallest number I have to find that is divisible by all the numbers. Okay, so the number will be greater than 1, 2, 3 or less than that. It will be greater than, na? Because I am trying to find that number which is divisible by 1, 2, 3, 4, 5, 6, means all the numbers till 10, right? Means I need to find that number which is a multiple of 1, 2, 3, 4, 5, 6. Hope it is clear. If a number is divisible by all of them, means that is a multiple of all these numbers, na? So, and you can also find like that as well, that the number is divisible by, so this number should be divisible by 2 as well. Okay, the number should be divisible by 3 as well. Number should be divisible by 4 as well. Means this number should be a multiple of all these things, na? Means the number will be greater than that. If a number is greater than that or a multiple of that, multiple means LCM. So we have to find the LCM. Indirectly they are asking us to find the LCM. One trick is there. Whenever your answer, you think your answer will be greater than the given numbers, it means you have to find the LCM. And it is also given here that you have to find the number which is divisible by, means the number will be in the numerator, right? Number will be greater. So it will be a LCM. Clear? So whose LCM I have to find? Of 1 to 10, means LCM of the numbers from 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Right? Okay. So how to find the LCM? We have again two methods, right? So if we try to find the factors first, 1 will be 1 only, 2 will be 2 only, 3 will be 3 only, 4 will be 2 into 2, 5 will be 5 only, 6 will be 2 into 3, 7 will be 7 only, 8 will be 2 into 2 into 2, and 9 will be 3 into 3, and 10 will be 2 into 5. Now if I am asking about the LCM, just tell me what is the highest power of 2 here. 2 to the power 1, here 2 square, here 2 cube, means 2 cube is the highest power, na? So 2 cube will be there. Okay. What is the highest power of 3? 3 to the power 1. 3 to the power 1 again. Here 3 to the power 2, means 3 to the power 2 is highest. So 3 to the power 2 I need to write, right? Now coming to the next, after 3 what we have? We have 5, right? So what is the highest power of 5? 5 to the power 1 and 5 to the power 1, right? So 5 to the power 1. After 5, the next prime is 7. See? 1, 2, 3, 5, 7. 7 to the power how much? 1 is maximum. So into 7. So this will be your LCM. If I try to find it, what I will get? I will get 8 into 9 into 5 into 7, right? So it will be equal to 2520. Clear? How to find the LCM? And this is also clear now why we are finding the LCM, why not the HCF in this question. Okay. Hope you liked the video. If yes, hit the like button, subscribe the channel and stay tuned for the next part. Thank you.
Like and subscribe.